We finished example 3 yesterday in this class, baby barely, as the bell was ringing. And we're ready for example, 3B. Okay, so we were at the point we're talking about domain. Okay, domain on the graph is how far left or right you go. The last step I'm going to have us do is I am going to have us graph this and see if our answer makes sense. What I want to do right now is try and figure out the answer without looking at the graph. Because there are times we have to be able to figure out the answer without knowing the graph. So, above we had like 4 different suggestions, right? Number 1 just says that all polynomials have infinite domains. Well, when you got x's in the bottom, that's not a polynomial. Okay, so don't have to worry about that. What's the second thing say? Denominators can never equal 0. Are there values we could put in this denominator would equal 0?
Yes.
Yeah. There are, aren't there? And so what we do to figure out the problem places is we set our denominator equal to 0. So we're going to take x squared minus 25, and we're going to set it equal to 0. And we're going to solve. How do you solve x squared minus 25 equals 0? Well, just think actual solve, though. If we're going to solve, if it's x squared minus 25, we're going to add 25. So x squared equals 25. And then? Square root. When we square root, what do we get? Plus or minus 5? Okay. When you're in an equation setting and you take the square root of both sides, plus or minus, right? Account for both roots. Now, what this is saying, because this was the denominator we set equal to 0, what we know now is that x cannot equal 5 or negative 5. The graph will not exist at those 2 points. Okay, so that's not just our answer, but that's part of our answer we need to consider, is that x cannot equal positive 5 or negative 5. Okay? This one, if you go back to your list from above and you look at item 3, item 3 talks about square roots, right? And what has to be true of square roots? Whatever's under the square root must be positive. So in this case, under my square root is just x, and so that's telling me that x must be greater than or equal to 0. Okay? I would say solve, like up above we had to solve, didn't we? There's no solving. X greater than or equal to 0 is just x greater than or equal to 0. So those are the pieces. By just looking at the equation without graphing, those are the pieces we know. Now, think about in terms of a number line what this means. Okay, I'm going to put some key points on here. Negative 5, 0, and 5, because those are the numbers we talked about. Now, think about this. First thing we figured out is that x cannot equal 5 or negative 5, right? So that means, you could think of it as there's going to be holes there, whatever it is. Whoops. Yeah, I guess I'm just going to leave it as holes, okay? X cannot be negative 5 or 5. There'd be holes there, right? Some type of gap. What's the other piece we know?
It has to be greater than or equal to 0.
Okay, it has to be greater than or equal to 0, which means, like, if we're thinking shading, that means I'm going to shade everything to the right of 0. Which means I'm going to shade everything over here except what? 5. We're not going to shade 5. Because we already know 5 can't exist. What's that mean to the left of 0? That's all a no-go. Okay? Now, if we think in terms of interval notation, because I'm ready to write my answer. If we think in terms of interval notation, where is the first place my graph can start existing? 0, yes? Because it has to be greater than or equal to 0. So 0, is that 0 with a bracket or a parenthesis? Because it said greater than or equal to. So we're going to think bracket here. Comma. How far does this interval go?
4.
technically 4.999999, you know.
Mhm.
How do we represent that? It's going to the number 5, except we use a parenthesis. Because
Cannot.
by putting 5 with a parenthesis, that means it goes up to 4.9999 infinitely. Now, is that it?
No.
No, because then what?
Then it can go more to infinity.
Yeah, because then it picks up on the other side of 5. So I use 5 again with a parenthesis, 5 to infinity. And infinities always use parentheses.
Oh my gosh.
Now, we did that purely based on the algebra, yes? I don't have this graphed yet, but let me get this graphed real quick. And you can graph it if you want, or you can just rely on mine in this case. I'm going to do zoom 6 because you can't see what I'm graphing.
No,
That's
just
okay.
algebras.
Algebras is all nice and good, but
Algebras.
okay, here we go. Now, on my 10 by 10 screen, that is what my graph looks like. Okay? You can use trace to kind of examine. Notice it usually plops your cursor on the y-axis. It shows it 0, 0, yes? What happens if I arrow left? My y value ceases to exist, which means my graph does not exist over there. It's not that it's just off the screen. It does not exist. So any place I go left, my y value does not exist. So now if I go back right, okay, now my y value exists at 0, 0. As I go right, notice my y value is existing, yes? Now, any thoughts on what's happening here? What is there that we can't see on this graph? If I've got one piece of the graph going down and one piece going up, what is that? Do we know? I don't know if we know it or not, but we don't know.
No.
How about if I say the word asymptote? Like a vertical asymptote?
I don't like those.
Okay, well, we're going to do a lot with vertical asymptotes, so. Now, and here's the deal. There's a vertical asymptote there, so what's happening is, really the graph probably goes all the way down and all the way up, but the graph calculator just doesn't show it. But what's happening here is if you watch, it's 4.69, 4.84, and then at 5, notice what it says.
No lie.
It doesn't exist. There's your vertical asymptote. Then if I keep going right, notice now, where did my cursor pop up?
Up there.
Up above. And so now it's going there. Does this interval notation match with what we just showed on the graph?
Yes, ma'am.
My x values start at 0. They go very, very close to 5. They take a break at 5. And then they continue 5 to infinity. Could you have just used the graph and gotten the same answer? You can. But you have to understand what all this means on the calculator. My encouragement right now to you guys is that we kind of use a combo deal. I encourage you to think algebraically like we just did, but then to back yourself up with the calculator. I encourage you to use them hand in hand. Some of you will try and just do the algebra. Some of you will try and just do the graph. My suggestion is try them hand in hand. Fair enough? Okay. Couple more domain on the back side. Couple of, well, at least one of them is kind of a special case. Okay, again, we're being asked to find domain. C, A of S is equal to square root of 3 over 4 times S squared. Any thoughts? Skip it.
3 has to be greater than or equal to x. No, x has. You understand where I'm going?
Okay, so you're looking at the fact you see a square root. So I need to set whatever's under the square root greater than or equal to 0.
Yes.
Except,
Oh.
that's not where my variable is.
What?
Okay? So that whole square root rule has to do when there's a variable under there. Right now, it's square root of 3. 3 is the only thing under the square root. That's positive. That's not an issue.
Wait, so
Okay.
if the square root has a variable,
You set it greater than or equal to 0. Okay?
4 can't equal 0, but it literally can't, right?
But,
4.
and again, we run into the same situation. If there's a variable in the denominator, it cannot equal 0. So this fraction and this square root is just it's a fraction. It's just part of the problem. You need to focus on the variables. Okay? So we need to focus on s squared.
Set it equal to 0. Now, how are you going to do that?
divide
Well,
Square
root. Okay.
being multiplied so you have to
no. Okay. Without grabbing the calculator, can you visualize this graph?
No.
Oh my gosh, but you could just put it in your
You could, and we will here in a moment, but I'm trying to push you farther. What do we know about this graph?
Oh, yes, because
Is it a parabola?
y equals ax squared.
Is this in the form y equals ax squared? It is. It's just in terms of a and s. So a equals as squared. Okay, overlap there. So now, okay, so a couple of things. Generally speaking, there is a catch on this one, so hang with me. Generally speaking, yes, this is a parabola like this. Okay? It's a parabola like that, generally speaking. And in that case, what do you know about the domain?
Real numbers. All of them.
All real numbers? Because what's happening? How far left does that parabola go?
Forever.
As it's going up, it's going forever left. How far right does it go?
Forever.
Forever. Now, and again, I'm going to put this up here that just generally looking at the equation, yes, it is all reals, or you could say negative infinity to infinity, but there's a catch, and the book's going to argue that this is not the correct answer. Okay?
Is there excluded numbers? Let's just do it.
Now, it's not about looking at the graph. It is truly a parabola. A parabola does have all real numbers, which is why I can say just looking at the equation that it is all real numbers. But this is not a formula you recognize. But what do you think about big A usually standing for? What does big A usually stand for in a formula?
Area.
Area, yes. Okay. So S. What does S stand for in an area formula?
Side.
Side of a square or triangle. Side of a square or side of an equilateral triangle. Okay? So here's the deal. This is the formula for the area of a triangle, of an equilateral triangle with side S. Now, if I put that statement out there, that this is area of a triangle with side S, what do we know about side S? What kind of numbers can only work for side S?
Positive.
Positive, yes? Can the side of a triangle have a negative value?
No.
No. Can it have a 0 value?
No.
No. So, again, it's a special catch. I don't remember off the top of my head if there's any like this in homework, but here's the catch. Because this models an area formula, then that S has to be a positive value, as in like S greater than 0 or 0 to infinity. So it's the idea that in this situation, this piece would not exist and just this piece would exist because this models an area formula. Okay, so I'm going to say this formula is area of a triangle with side length S. Okay, so that's kind of the special caveat here. So because it's area of a triangle with side length S, you can think about it as the fact that S has to be greater than 0. Or what is that in interval notation? It is
0 to infinity.
0 to infinity, parentheses on infinity, and
On 0.
parentheses on 0, because can the side length equal 0?
No.
No. Special catch, yes?
Yeah.
If you just look at this as an equation and don't think in terms of area, I agree it's all reals. It's a polynomial. Okay, it's a parabola if you look at the graph. Okay? Let's try D. F of x equals square root of x squared plus 5 all over x. Okay.
Equals 0.
What do I say equal to 0?
The denominator.
Okay. Anytime you have a variable in the denominator, we're going to set equal to 0. So one of the things I'm going to do here is set that equal to 0. Now, normally I would say solve, but x equals 0 is the solving. And so what this is saying, whatever's in the denominator, x cannot equal 0. So whatever my domain ends up being, 0 will be excluded. Okay? That's what I know so far. So every problem you see, when there's a variable in the denominator, set equal to 0. What else do I need to consider?
X squared plus 5 is greater than or equal to 0.
Okay. Whenever you see a square root with a variable under it, whatever is under the square root, you set as greater than or equal to 0. So x squared plus 5 greater than or equal to 0. Officially, we solve this, right? How do you solve x squared plus 5 greater than or equal to 0? Subtract 5. X squared greater than or equal to negative 5.
Is this gonna have an imaginary number?
Okay.
No.
Now, we're not talking imaginary numbers, okay? But that's kind of your warning clue that, okay, wait a minute, what's going on here? We got to think about this, okay? So, yeah, you go to take your square root and you're like, wait, why are we talking imaginaries all of a sudden? Think logically. Whatever x is, right? When you square it, it has to be greater than or equal to negative 5, according to this. But what happens when you square any value? It becomes a positive, yes? If you square it positive, it's obviously a positive. If you square a negative, it becomes a positive. And so the idea here is this actually ends up not mattering. Because it's already x squared has to be greater than a negative. That's guaranteed to be true. It doesn't matter what x is. You square something, it's going to be bigger than a negative. So this one, what I'm going to say here is this one is okay in the sense that it's not going to affect our domain. Okay? I'm going to say okay. I will say already positive because of x squared. Okay, so essentially what I'm saying is, well, yes, we had to think about this one. This one ended up not mattering. Okay? So, what's the only actual piece of information we came up with that matters?
X cannot equal 0.
X cannot equal 0. So, my thought is, what's that? Think a number line. What's that mean to you on a number line?
Has to be a positive.
Well, it can be a positive or a negative.
It can't equal 0, so it's like there's a hole at 0, but x could be positive or x could be negative. How do I write that in interval notation?
Negative infinity 0 parenthesis and then 0, parentheses, infinity.
And I put a U in the middle for union.
Yes.
Okay. What that statement is saying is that everything but 0 is included. Now, I think some of you have taken a peek at the graph. Some of you have not. Root of x squared plus 5 over x. And here's the deal. I think I know what my answer is, don't I?
Mm-hmm.
I want to see, is it? Is this my answer? Does that make sense?
Yeah.
We claim negative infinity 0, 0 to infinity. Okay, so we start looking over here. The graph goes infinitely left, doesn't it? And then what's happening? As it approaches the y-axis, it's heading downwards, yes? What is that y-axis acting as?
No go.
Asymptote? Vertical asymptote?
Don't like that word.
Okay. The same vocab word I threw out at you, right? This one just shows a little bit better. But this is a vertical asymptote. So it goes down here on the left side of 0, and then it starts over on the right side of 0 up high. So this matches. Now, could you have gotten that answer by looking at the graph? I would like to think so. But that's a learning process, right? So this is why I say use both. Okay? Me personally, there's a difference here. You know I'm the math teacher, so this material, I know it. I can look at this and be able to look at the graph. So, if you tell me, yeah, I think I can get that from the graph, I believe you. But if you're not quite there yet, I also get that. Okay? And again, tracing, you can use the trace to kind of get an idea of what's going on. Okay? So tracing will tell you a lot if you watch those x and y values. Okay? Okay, that's domain. Domain's probably the one that we have asked more, and it comes up in more scenarios. Oh, I was going to sketch a graph over here. In that it's what we will learn to be a reciprocal graph here next week, but that's for next week. Okay? Range?
Let's do it.
Okay, now, range. The same rules apply to an extent, where we can consider things like denominator cannot equal 0 and square roots have to be positive. However, here's the deal. Before you can apply those rules, your equation has to be solved for x first, and you're looking at the y's. That's sometimes pretty easy to do. That is sometimes not so easy to do. And so the backup method, which I know is going to be a work in progress, the backup method is to, read the graph. Okay, domain, we read the graph left to right. Range, we're going to read the graph bottom to top. We did this a little bit in Algebra 2. Okay. We did. And I say that just because I've already taught it this year in Algebra 2. So it would have been like a year ago. That's, long time ago. So, as we look at this first equation, first of all, you guys know, what is f of x? That's y, yes? So this is the same as saying y equals 2 over x. This one's pretty easy to solve. Solve this for x. Make it x equals. How am I going to make this x equals?
Could you multiply by x and then?
Yeah. Work to get x out of the denominator first. If it's 2 divided by x, how do you move a divide by x? You multiply by x. If I multiply the left by x, I multiply the right by x. So now I have xy equals 2. How do I solve for x? To get x by itself, I'm going to divide by y. So I end up with the equation x equals 2 over y. Okay, so this is the equation we can use. Now here's the deal. We can't graph that equation right there. Because you graph that equation right there, we don't have it as y equals. But use the rules from earlier. Square roots and denominators. What do we know here?
Y equals
Yeah.
y.
Whatever's in the denominator, set it equal to 0. So in this case, we're going to set y equal to 0. And whatever we set in the denominator equal to 0 cannot equal 0. So one important piece I know is that y is not going to be able to equal 0. Any square root to worry about? No. This is probably the only issue. Now, if y cannot equal 0, you can write interval notation at this point. Okay? I know these are y's, but you can think about it just like we did on the previous problem. If y cannot equal 0, what's that mean? Whoops. There's a hole at 0, but everything else exists, doesn't it? So, what is this in interval notation? Same as the last one. Okay. Technically is in terms of range instead. So, it's negative infinity to 0, union, 0 to infinity. Now, I do want to look at the graph, because I want to talk about how to read the graph. With this in mind, what am I graphing? You're graphing the original graph. Okay, so if you're going to look at a graph, graph the original graph. So y equals 2 over x. Kind of looks similar to the last graph, doesn't it?
Yeah.
Now here's the deal though, not domain. This is range. How low does your graph go? Is it going down off the screen? Yeah. Then, okay, as it's coming up, as it's moving up the graph, what happens? It veers to the left, and what's it doing as it veers to the left? It's continuing, and as it's heading off left infinitely, it's getting closer and closer to what y value? 0. It's getting closer and closer to 0, because guess what's happening on the x-axis? There's an asymptote. It's horizontal here. Okay? Now, to be honest, this is giving me a lot of fractions. I don't really want fractions, so I might be able to show you in terms of decimals. Oh, well, it's off center, but okay, there we go. Gives me some decimals. Now, watch the y values. Negative 0.2, 0.1, 0.09. It's getting closer and closer to 0, but is it ever going to reach 0?
No.
Not if it's doing something like that. And so that is how you can look at the graph. Okay? Okay. One more. Okay. This would be equivalent to say y equals x squared over x squared minus 1. To be honest, if we start this one like the same way we started last time, that means I'm trying to take y equals x squared over x squared minus 1, and I'm trying to solve that and make that x equals. I'll be honest, not quite as easy as last time. Nope. Yeah, it's not pretty. Mm-hmm. You're still going to have the fraction in there then, though. I mean, like, if we start this and multiply by x squared minus 1, then we're going to have x squared minus 1 times y equals x squared. So one of my x squareds is going to be times y, the other x squared is not. This one's not going to be pretty if we try and solve it for x. So my suggestion is going to be that we read the graph. So I'm going to write on here, read the graph when difficult to solve for x. It's a fun graph, isn't it?
No.
You don't call that fun?
Not when I gotta read it.
Hey, at least I'm getting you practice on using the graphic calculators, right? Okay. Does yours look like mine? Whether you want it to or not? And let's see. Okay. That's the graph we're looking at, yes? You with me? You ready to try this? Now, we're answering what type of questions? We're looking for range. So you start by asking yourself, how low do you go?
Negative infinity.
Can we at least agree on that part?
Yes.
We at least have the starting point. Okay, this graph is moving down there, right? So my answer is going to start with negative infinity. Now, as you follow that up, how far does it go before we have to take a break?
0.
Because you have this kind of upside down parabola, yeah? And as you trace it up, it's going there. Is it touching?
Yes.
And here's the nice part. When you hit trace, it's putting it exactly on that point because it puts me on the y-axis, right? So it's saying it's on 0, 0. And you can tell by looking, that's the highest point. So this is going to go to a y value of 0. Parenthesis or bracket. Because this actually went through the y value of 0, didn't it? Okay. Union. Now, what's the next y value that becomes important?
0. Well, it's close to 0, but it's not touching 0. What are you talking about? Like on the last one, where we would read it as like it's close on the lines to 0, but it's never gonna touch 0.
So, Katie, you're guessing that there is a asymptote on the x-axis, right?
Yes.
Now, normally I would agree with you. It's not exactly on 0. 2 ways I can tell. One way, I just said this graph goes up to 0 and includes 0. So I'm probably not going to have the next piece start at 0, if that makes sense. Now, Caitlin, how did you come up with your 1?
I went up to like 1-ish and then went over.
Okay. Here's my suggestion. Start tracing either left or right. And if you start tracing left or right, I'm trying to get to the lowest y value in this section, yes? Watch your y values. It doesn't matter if you go left or right. What are my y values getting closer and closer to?
1.
Yeah, I'm at 1.00, well 2, now 1.001. Folks, if this was approaching 0, we would already be at 0 point something. But the fact that I'm at 1.00 something, that tells me that there's an asymptote at 1. Does that make sense there?
Mm-hmm.
Okay, and give it later in this lesson and we'll talk about how you can know there's an asymptote there at 1. But I know you guys can't see it right now. But there is a horizontal asymptote at 1, which means, okay, my y values ended at 0. Where are they going to pick back up at?
1
1
parenthesis.
with a parenthesis because that 1 is an asymptote. We're not actually going to touch 1.0. We're going to get very close to it. And then we're at the 1. How high does my graph go?
Infinity.
Infinitely up. Okay. It's a work in progress. It's a learning game. It really is. I know. So your homework is on page, what'd I say, 92?
Yeah.
And for this part 1, it is just 2 through 20 evens. Maybe I should make that all, but I didn't. So it's not a ton of problems. But your job is you're answering some function questions, some domain, and some range. Really put some effort into trying to figure them out.
You know
And then we will talk tomorrow.
how weird it feels to actually understand domain